electrodes that you could even purchase. Probably be best to let this one soak in the solution for maybe 20 or 30 seconds. But only thing you're going to change is that hundredth of a decimal place, and I don't think that's for our purposes even worth considering doing. Okay, so I've rinsed it off again. Now we're going to go to the next series. The next series we're going to look at is going to be for the acetic acid. So we're going to go over to the acetic acid and pick up those three. So now I've got the acetic acid at all three concentrations. We're going to start with the highest concentration first. So going to the acetic acid, I have the 0.1 molar acetic acid. So I'm going to put that in the electrode. Now acetic acid is a weak acid, so it only partially ionizes. So I'm not expecting it to be down close to pH 1. In fact, if I look at the pH, it looks like it's 2.8 something. We're going to let it sit a second. All right, we're going to call that good enough. 2.81 at this point. So 2.81. All right, so we're just going to repeat. So we're going to flush it a little bit. Let it dry. Now we're going to go to the 0.01 molar, so the 100th molar acetic acid. We're going to give that one a second to, it looks like it's going to be somewhere in the neighborhood of 3. All right, it looks like it's stabilized at 3.01. So 3.01 on the 100th molar acetic acid. All right, rinse it. Go to the next one. So now we're going to go to the 1000th molar acetic acid. And we see this one, the pH doesn't change as much between the steps with this one because it's a weak acid, and even though the concentration is going down, it's starting to dissociate more because the dissociation is a function of concentration. So this one gives me a pH of 3.30. So 3.30, or it changed to 1. I've already written 3.30 down, so I'm not going to stick with that value. Okay, so that's both of the acids we need to look at. Now we just need to repeat the experiment right quick for the two bases, and we'll have all the data that we need. Okay, so switching over, I'm going to blot it first. Switching over to our bases. We're going to start with the sodium hydroxide with the strong base. And we're going to start with the highest concentration, just doing everything in order. So it's the 0.1 molar sodium hydroxide. Now, this is going to have a high concentration of the hydroxide ion, the OH minus, so I expect the pH to be pretty high. Right, so this is going to be the opposite of the acid, because as the pOH is high, that means that a high pOH means that it's a low number for pOH. So let me say that again. A high concentration of the OH minus means that it's a low number for the pOH. So that means that pH is high, closer to 14. And on this one, it still hasn't stabilized yet, so we're going to give it a second to try to get maybe a stable reading for us. And it's still a climbing, so we're going to let it keep going just a second. All right, It's finally got the S, so it's pretty close to being stable. So I'm gonna go 11.8, and we're just gonna pick a number here because it's still slowly going up, and we're going 11.85. So 11.85. Okay, and I know that was still slowly climbing, but if we sat here with this electrode, if we sat here for an hour, it would probably still slowly climb up. So we just have to take a number and give a set period of time and go with it. All right, so now we're going to do the 0.01 molar NaOH. Now this one's a little odd because the previous one I expected the pH to be higher, closer up to 13. That's what I expect to get, but this is where it shows the weakness in this pH electrode, because this value is very, very close to what the theoretical value should be. It is showing a pH of 11.94. And it would make sense that the one that is a higher concentration of the strong base should have a higher number for pH, but that's not what our pH meter is telling us. So this is where you start to learn some of the limitations of your instrumentation. You could solve this problem instead of using this cheap pH electrode like I'm using right now. So these are a freshman level grade. These electrodes like this cost in the neighborhood of probably $75 a piece. The ones I do in my research lab, they cost $500 a piece. And I consider them consumables. I at least replace one of those about every year while I'm using them. All right, so looking at the solution that is 0.001 molar sodium hydroxide. So 0.001 molar sodium hydroxide. It's going to be the last column. And if I look at the electrode or the pH meter, it's reading 11. We're going to go with 11.16 as a reading on this one. And they're continuing to change a little bit. So last series of rinses. All right, so now we're going to go to our last reagent we have to look at, and that is the ammonium hydroxide. So we're going to do this ammonium hydroxide. Start with the 1/10. So here's my 1/10 molar ammonium hydroxide. So we're going to put that in the solution. Stir it around a little bit. Okay, looks like the pH is about 11.04, and this one doesn't seem to be drifting near as much. As soon as I say that, it changed 100th. But we're going to go ahead and go with the 11.04. Give it a quick rinse.